Okay, in this problem, we want to find the equation of a plane containing the point -4, 1, 3, and containing the line given by the parametric equations x equals 1 plus 2t, y equals 3t, and z equals 4 minus 3t. I have attempted to picture the situation down here. I'm calling the given point, -4, 1, 3, I'm calling that P. That's in my plane, and the plane is represented by the parallelogram here. You're supposed to imagine that that looks like part of a plane in space. And then also my line is pictured here as well. So it's really important that you realize to find the equation of a plane you need two things. You need a point on the plane, we got it, -4, 1, 3. And we also need a normal vector. We don't have it. So how can we get it? Well, we can find a couple of vectors in the plane. Here's how we could do it. The parametric equations can generate points in the line just by picking different values of t. So if I plug in, say, t equals 0, I'll call that point Q. If I plug in, say, t equals 0, I get 1, 0, 4 for my point Q. And then if I plug in t equals 1, I can get another point, call it R. And then I get, if t equals 1, I get 3, 3, 1 for my point R. Now, I'm going to find the vectors PQ and PR. By the way, another vector in the plane you could have used is 2, 3, -3, the direction vector. That's also could be considered as being parallel or in the plane if you put a copy of it in the plane. So that would work as well. But this is a good way to do it as well. Oops. Let me get things lined up a little better here. Okay, so there's my vector PQ. There's my vector PR. And the idea is if I take the cross product of PQ and PR, I should get a vector that's normal to both PQ and PR, and therefore normal to the plane. And so that's how I can get a normal vector. All right. So how can I find PQ? Well, in the usual way, Q is the terminal point, P is the initial point. 1 minus -4 is 5 for the first component. 0 minus 1 is -1 for the second component. And 4 minus 3 is 1 for the third component. That's PQ. PR, minus a -4 is 7 for the first component. 3 minus 1 is 2 for the second component. And 1 minus 3 is -2 for the third component. Okay. So let's go ahead and find PQ cross PR. Whoops. PQ cross PR. Okay, create your pseudo-determinant. I, J, K across the top. In the middle, 5, -1, 1, and then 7, 2, -2. Okay. So the I component, remember, cross out with I corresponding row, corresponding column, and you'll get the sub matrix -1, 1, 2, -2, which you take the determinant of to get the first component. Minus, cross out middle column, top row, the determinant of 5, 1, 7, -2 is your J component. And then plus, I don't think I'm going to have enough room, so I'll write it here. Cross out third column, first row, determinant of 5, -1, 7, 2 for your K component. Okay. So that turns out to be, okay, 2 minus 2 times I, so that's just 0I, the I component zeroes out, minus negative 10 minus 7j, if you figure this middle determinant, and then plus 10, okay, 10 minus a negative 7 is plus 7. Okay. So you end up with, when the smoke settles, you end up with, what, 17j plus 17k? Well, okay, that could be your normal vector, but why not divide out the 17? Because any multiple of, so multiply by 1/17, divide out the 17 in other words, and any multiple of this cross product is also a normal vector. So I'm going to actually take my n to equal j plus k. And then remember, you're going to fill in the general equation of the plane is a times x minus x1 plus b times y minus y1 plus c times z minus z1 equals 0, where a, b, and c are the components of your normal vector, so that's going to be 0, 1, 1, and x1, y1, z1 is a point on the plane. You can just take the given point or any other point we found. The given point is negative 4, 1, 3. So if you fill in that equation, then you get, well, this first guy just zeroes out, so you get 1 times y minus y1, or just y minus 1, plus 1, that's the c, times z minus z1, which is 3, equals 0. Or, whoops, let's see, that'll be y plus z minus 4 equals 0, or y plus z equals 4 if you move that 4 to the other side. That's it.